Hello, I am Brent Gill. I'm the president and the founder of Gill Trading. We manufacture automated cleaning systems for water treatment and wastewater systems. We're here to talk today about the Weir washer automated cleaning systems that is used to remove and control algae, grease, and foam from clarifiers, thickeners, and other tanks and applications throughout the process. We're going to specifically today learn about the submerged articulating spray apparatus that is used on clarifiers that have ducking skimmers or any type of horizontal surface obstruction on the tank, which the Weir washer submerged articulating sprayer ducks under those obstructions and then automatically comes back up on the other side. So, hi everyone. The Weir washer has been around for now about 22 years. Designed it back in 93-ish for the first unit, and it's been a project that I now live off of for the past 50 or 18 years. The Weir washer uses your reuse water to cut algae, grease, foam, and other materials off of tanks and thickeners. And what we're going to do here is go through the basic process of what has already occurred in the tank, but you can see a little bit more detail on the exact installation locations without having to climb into the tank. And just talk about some of the basic aspects of installing it so that you know when we go out there what to look for, and maybe answer some of the questions as to why certain things are done the way they are down in the tank. How the Weir washer works. So we tie into the existing non-potable water, your reuse water. I think it's W3 water here in California. Yeah. And we go through a solenoid valve and a timer. In this instance, there's no manual bypass. This solenoid valve, which we'll get into the more intricate detail workings of the valve and how it operates the articulating arm in the next set of PowerPoint presentations. Right now we're just going to get into the water distribution, the center unit, the theory behind how that all works, and then the second set of slides we'll get into the exact details of the articulating spray apparatus. We basically tie into the existing water supply, go through a solenoid valve and a strainer, which is there already. Here's an example of various different types of solenoid control valves. Your system is tied into a Hunter control valve. Many other facilities tie directly into the SCADA control, which they have here. Another operation where they went manual, just had a ball valve, and they actually also then did a weekly bleach where they tie into the sodium hypochlorite lines and weekly ran a sodium hypochlorite bleach through it. Cut their flow to the clarifier just enough to get their flow down, ran it around twice, let the bleach soak in, and then turn it back on, and they were able to bleach it completely white. Here's your basic layout. Once again, here's your small section, solenoid valve, the strainer. In your instance, the solenoid valve and strainer are up here in the center of the clarifier. The piping you already have running across the clarifier bridge. Then as we go out, you'll see the piping passes through the middle of the center of the clarifier and into the center column, which is right here, this non-rotating component. The outer rake arm rotates, obviously, with this water supply passing through the middle of the clarifier drive into the still stationary center column. It delivers water to the Weir washer center unit, or the center ring. And its effective design is comparable to a tire on the rim of a car, except in this instance, the tire rotates on the rim. The tire would be connected to the rake arm as it gets pulled around. The center rim, per se, item is UHMW polyethylene plastic, and it's C-shaped. The UHMW fits inside the stainless steel outer ring. When you pressurize the ring, the plastic swells into the ID of the steel. The steel is buffed roughly down to a 10 RMS, or near glass mirror finish when we ship it. And all those equipment pieces before when we ship them here are already tested without any adhesive in them at all. The center unit has leakage. If you don't, and I've learned this the hard way, I made rings that didn't leak at all. And then the sand and grit and snail shells and everything else that likes to accumulate on any horizontal surface, especially in a secondary clarifier, worked in between the seal faces and tore up the ring in a matter of 2 to 3 years. It was gone. Steel was fine, but the plaques was trashed.
So how long will the center ring last?
We're on average 9 to 12 years right now for the old models. that were running roughly 90 to 100 thousandths thickness on the plastic. Now, with what we've learned on some of the units we've had a chance to go in and look at, we've changed the design, improved it where we saw the wear areas. It used to be so that the steel was right over the plastic area itself, or the plastic fingers would swell into the steel. Now we actually have the steel where it rests right over solid plastic, so it can actually wear into that solid plastic longer. And the plastic fingers themselves, instead of being roughly an 1/8 inch thick now, are almost a 1/4 inch thick. And there's inside that plastic, there's a piece of spring steel that's laid up in there. If you ever get a chance to look at it, it's basically wavy wafers that push every 1.5 inches. There's a spring pushing on both sides, so that when the unit is off, this plastic is steel swelled into the steel, creating roughly a 5 to 7 pound sealing force. When you pressurize the center unit, because the UHMW is flexible, very flexible, the water inside forces the plastic into the ID of the steel. As you increase your pressure in the water, you get more sealing force. So it's equivalent to a bellows mechanical type seal, whereas you increase pressure, you get more force, so that your sealing force is roughly compensated. Now, the center unit is rated for 150 pounds continuous use, if you want to run it up that high. The outer ring of the center unit, the stainless steel part, which is the large part you'll see, has braces on the outside to prevent it from over time actually expanding. Those are added because the plastic on one unit after 3 years took the steel and swelled it open 1.5 inches until it popped off. And the stainless steel looked like this. So,
Brandon, got a question.
Yes, sir.
So right now we have 2 of your units.
Yes, sir.
Secondary clarifier number 1, where we are kind of used to seeing for the last 18 months of operation. Okay, that's kind of like a point of reference.
Yeah.
Oh, well operating, well washer should do this.
Right.
And then on number 2, it seems like it has less force on the nozzle, and then more is leaking through that center seal to me.
Right.
So I want to get your opinion on that, because you're the manufacturer.
It's also manufactured different. It's inverted.
Yeah. The arm has changed. So you've seen the spray apparatus on the first one, and you saw its massive side and the water size. The water came around into the one side, and then it was fed back in, and then the brace and the bearing was set on that one side. And we'll get into that. But now the water feeds in straight through the rotary bearing, and the bearing is right. The other secondary, or let's say actually the primary bearing, the rotary bearing that the water flows through is a secondary bearing. That has plus or minus 1/8 inch play, and so I put a 1 inch stainless steel bearing on the other side, which both units have. It's just that it was reversed when we ran the water around.
Well, he's talking about the velocity of the water.
Right, and that's what we can.
The first one, the sprayer's on top of the arm.
Right.
This one,
it's
underneath.
But it won't affect.
And it doesn't spray anywhere near as hard as the other one does.
And that's what we'll get into. I'll go out there and look at that, because there's at least 2 of the nozzles are completely clogged right now, and we haven't had a chance to pull the strainer out. I haven't looked at the system at all.
All right, so that's part of your plan.
That's what I'm going to be doing while I'm here. Yeah.
All right.
We'll evaluate water pressure down the line, what it starts out at, and where the stop is.
Just to provide some background from the end user's perspective.
Yes, sir.
After it was installed, I don't think any kind of testing was done until today. So this is the first time for us witnessing operation.
Well, they know that the they know the proc switch worked, because they did install it and put it up inside the cover and ran metal underneath it, so that it did rise and lower, and they had that as of last Tuesday or Wednesday. So they knew that the electrical system was working, and what they're working on right now is the exact timing of where it's going to duck and where it'll come back up again. But they did know that the electrical, because I have an email saying on Tuesday, well, we're going to wait till you get here. Like, no, I strongly recommend you make sure your electrical works before I get here. And they said, yes, it works. We just want to get your timing, experience and recommendation. And ultimately I said, copy that one. But they just want to make sure they do it right. So, and we will get into all the details of the spray apparatus as far as spare parts recommendations and discussions about how the cylinders work in detail. And well, I'll be a whole nother 9-10 slides after this basic run through in the center unit. And then the outer ring is stainless steel connected to the rake arm, and the chains that connect to it actually pull it and cause it to rotate, which we'll see when we go out there. But the center ring has to leak. It is a self-flushing mechanism. It's what keeps the seal faces on the plastic and the steel from accumulating any of the other materials that are in there. And then piping down the rake arm. Piping on the rake arm is polyethylene. I've broken copper galvanized, stainless steel, welded stainless steel. I'm trying to think the only thing that never broke on that rake arm, because the rake arm vibrates and flexes and torques, we went with completely floating metal piping. It still snapped off at some of the joints. The only thing that survived on that rake arm was polyethylene pipe. And Half Moon Bay up in Northern California has been running their poly pipe with zip ties for the past 16 years. Because they never went back in and put the metal straps back on. And so it was a customer install. And I said, you could do this, right? Like, yeah, we'll get it done. Yeah, it never happened. So it's still 16 years on zip tie.
Pretty impressive.
Yeah, zip ties are huge. But anyway, that being said, they're putting hose clamps on to support it at the brackets. Where the piping is connected to the arm, it floats inside of a saddle, so that as the arm moves back and forth, it has small points on it, but it still allows the pipe to flex, bend, and move. So as the rake arm moves, it won't torque, twist, or destroy itself. And then up to the spray apparatus, which this section we'll get into. Now the rotating speed, I'll bring this up because I saw when I came out here, slower is better. The slower it rotates. When I was here, I think 2 weeks ago, when I was working with them on the installer, maybe a week and a half, the other one of the nozzles had clogged, and so it was running fairly fast, and because you can reach the nozzle, I just reached out and slowed it down, and instantly, when we were going, not real fast, maybe 60, 70, 80 RPM, go.
The reason why we have them turning fast is because they stop.
Okay, and that was part of my question to you. If that's an occurrence, then you run it at whatever speed.
Ever since it's been running like that, we haven't had a problem with it.
All right, and then then that's the question. Now, to compensate for that, you can jump up to larger nozzle size if you want, if you have the water, and then that'll give you more energy going out at the same time, and just bump up to 1/4 inch. You have to balance it out, your water flow relative to enough water volume to lift the arm, so you have to watch that balance. And if you just pull out one at a time, but if you have a 1/4 inch opening nozzle shooting out of there, and as you saw those nozzles, we can cover those now. Let's see what the next slide is. I haven't done this in a while. But the nozzles are hose barbs, but it gets into fundamental hydraulics. To have laminar flow, which is what we want. When it comes out of the nozzle, it comes out as a straight beam, not as it comes out as a spray. Because we're spraying it, 3 to 5, 6 feet through the air. We want to have enough of that energy concentrated into a small enough area where it'll actually cut the water, or cut through the water and the algae, and remove both the algae and even into the water. And by slowing it down, it allows you to penetrate deeper. But you can offset that, like I said, by going with more volume of water so that you have more energy going to the surface over a certain fixed time. So that's one way to achieve a little bit deeper cleaning under the water line. And as you're experiencing, it's one of those things that you have to work with it to figure out what works best for your application. And having it stop is useless. So finding that happy medium is the trick. So I'm just going to show some sample applications. This is up in the northern zones where things freeze. And piping down through, in this instance, here's your center unit. You can't see it, the water feeds down through the middle of the clarifier right here, into the back of the plastic ring. Here's your stainless steel outer ring with the chain going to your torque tube, your vertical torque tube that goes down to your lower rake arm. And here's your water supply. In this instance, instead of running down, we had a full surface skimmer, so we ran the piping across the top of the skimmer. And clamps. Same saddle mounting. This is a center feed wheel sprayer, just FYI. It's just a big rotating spray bar that chews up the angel food cake that likes to grow on some of these clarifiers. And here's your saddle combination right there. I don't know if you can see it. And we use what currently was first installed was a stainless steel strap. Those are ASTM and, well, I know they're ASTM rated, and they're rated for 250 pounds and a 316 stainless steel, and I have a mil spec for them also. So that it is a rated and proven component.
From our preference, I think it will make us a lot more comfortable if those are thicker.
They're going to be hose clamped.
Yeah.
They're going to hose clamp them on. I already supplied it to them, and they're going to go in. Yeah, they were did.
Yeah,
okay,
just
good.
flagging it to your attention.
Yeah.
Not only
Customer's
secondary
choice.
clarifier number 2,
Right.
you're going to do number 3.
Right.
Potentially all of
Right.
IP1.
Right.
So, I don't want to talk about this every clarifier.
Oh, absolutely, and that's why on any future things we're going to make sure. That's why I'm here, to make sure this is all done. You can see as it just sweeps through, it's just sort of just laid up in there, because as the rake arm twists and moves, it allows the pipe to flex around. And just a basic spray apparatus. This instance, they didn't have a riser pipe. This is actually a thickener for a water treatment plant. So we installed a 4-inch sealed pipe, plugged, seal welded, and it's actually floating displaced its own weight. So it had a neutral effect when the tank was filled. But then just a real basic arm, and this is the same, the other thickener. And this arm actually articulates instead of horizontally around a concrete block. It sits here on many clarifiers, which you can barely see right there. Here's your feed water as it runs across the bridge. The piping flows down through the middle. This is a much larger hole because of its design. It was a completely sealed column, and so we had to do some things differently. So to mount the center unit, we put a large belt. This is a no-drill design. So there's this is one version of it. What we use now is an 1.5 inch thick, 1/8 inch or 1.5 inch wide, 1/8 inch thick with a 1-inch bolt, as you see there. You draw that strap down to the column, and that's your anti-rotation. This gap between the two flanges here, when you draw this bolt down, the weld seam of the column goes in between these two flanges. The weld seam actually is your stop. Number one, you're torquing it to 80 foot-pounds. It's nice and tight on there. But then also, the weld seam sits up against one of the faces of these clamps. And because of their design, when you tighten this down, it actually digs in. It's hard to see, but that is the weld seam right there. All these columns are made of flat plate that are rolled into round. And they're roundish, sort of round. Next step is, here's that strap. There's the plastic UHMW is 4 quarters that are put together to make one circle, and they set over top of these 2 bolts here and there. And there's 2 holes in the plastic, and it basically just sits like this, and the plastic sits down over it, and the stainless steel fits around the outside of the plastic. Here's the flange for the stainless steel outer ring, and here's your bolts that connect to the chain, and that chain is what transfers all the force into that flange and pulls the whole ring around. This band stops the inner ring from rotating. So here, in this instance, here's your feed water coming down. In this design, we went through the sidewall. On yours, we actually came through the outside and went into the top of the plastic ring. And then here's your water supply coming out. There's a chain there, a chain here, and the reversing chain goes back over here. I learned from real life that clarifiers do get run backwards. Not very often, but when it stops and they don't know why, they run it backwards.
Sometimes you get so good on the bottom of jam.
Right. And after I had 2 rings get ruined under warranty, I now have a reversing ring on and chain on there so that when it runs backwards, it gets pulled. Everything's good. That all sort of makes sense. Here's your poly pipe going out. Here's your feed water coming in. And there's your inner plastic ring. Here's your outer stainless. In this model, the column was a little bit bigger than what we were told, so we added some rubber shim in there. This is just another, it's a smaller, lighter grade version of what you guys have. But this has been in operation for roughly 9 years, this design, with a small cylinder, rotary bearing, and arm. But it just has to bend back and forth, and we're talking inch-pounds of force required to push it back and forth. So it's real small small item.
That's a ducking one too?
No, it just does
It
this.
just comes back.
Back and forth. It goes by this concrete block,
Oh, okay.
and this wheel just rolls by it, pushes it back,
Nice,
and then
roll on the wheel.
that
Got
teeny
it.
little cylinder then
Yeah.
pushes it back out
Yeah.
nice and slow. Real simple. I mean, it's not simple. It's taken me a decade to figure that little thing out. But it's the same effective concept. And just various different options of water supply piping. So squircular circles, squircles, we've done many different designs, configurations, the articulating obviously, which we'll get into. I've had to pretty much install on every clarifier now that exists. My last one is a square clarifier with a ducking skimmer. That's going to be tricky. Just to summarize, piping runs across the bridge, through the rake arm, through the center unit, down the rake arm to the spray apparatus. And all of the equipment we send out here, the spray apparatuses and the center units are pre-tested. In your case, we cycled the articulating arms 200 times in our own 8-foot by 8-foot by 6-foot wide test tank that we set up with a robot switch, and basically whenever it came up, it hit it, would drop it down, just cycle over and over and over. And just to make sure it's fully submerged, to make sure there was no issues. And then I crawled all over every weld, and I adopted each one of my little children that sits there, and to make sure that everything was lined up just right. And the rotating spray, the reason for rotating spray instead of fixed spray is we can cover a much larger area, roughly 10 to 20 times the same area, or of an area with, or 1/10 the water usage for that same area. So to state that more intelligently, to cover the same area with fixed nozzles, we need roughly 200 to 300 gallons per minute. We're now covering that area with 12 to 15. So assuming each nozzle does about 2 to 3 gallons per minute. And then just some of the various different designs, configurations. We've worked with a couple clarifier manufacturers where they want us to actually, I don't know if you have seen any gravity draft tube type designs where pipes across the floor come up, and instead of drawing it off the bottom, they actually draw the liquid up into an upper chamber, and then they draw out the RAS down a secondary internal pipe. Well, those clog up with baby diapers and tampons on a regular basis. So what they wanted us to do, incorporate that, the Weir washer, have a secondary feature of a draft tube purge valve so that they could direct the flow, cut off the flow to the spray apparatus and direct the flow through each draft tube and clean up the draft tube. Because right now they're just sticking hoses down. Just running with ideas here to let you guys see some different options that are available besides just what you have here. These are some of the things that in a facility, an organization as large as IUA, you have very, very unique applications throughout the whole process. And this is an octagon. It's effectively the same design, rotary bearing, and then we have a double bearing design. You have rotary swivel and a bearing on top. Then the arm sticks out anywhere from 8 to 20 feet. And then just real basic, static, fixed arm, rotating spray. And then there's a couple hundred of these clarifiers in the United States. Either you're able to increase your flow rate without inducing extra short circuiting, but they're a nightmare to clean. And here's just an octagon sprayer. Your basic rotary bearing, that's that main water swivel. The water feeds in first. That's a dual ball bearing, stainless steel on stainless steel. It inherently, by its design, has a mechanical seal top and bottom, and it's non-repairable. But these are API rated, not ANSI, so they're made for the oil and gas industry. These are, I think they're in the 5,000 to 8,000 pound load range, and we're putting 20 pounds of load on them. And they're rated for up to 200 RPM, and I think we have 1/4 an hour of rotation. So I've done everything I can to completely overkill these things. And then the second bearing that sits, spray bar comes out here, and we'll get into this more detail. The other bearing sits up top, and that's a 5,000 RPM bearing, rated for I think 10,000 pounds load, side load. And once again, we're doing 1/4 and 5 to 10 pounds. So. the basic concept behind the cylinder, your cylinder is the same design. Seal, rod, seal rings, and just bigger. And then with your cylinder, bolts in the face, and bolts in the back on the face as well. Water supply comes in on this unit, which we'll get into, has a union that unscrews, so the whole cylinder, once you unscrew that union, take the 4 bolts out and unhook the chain from here, the whole thing comes out. And it's made by SMC, not in this one doesn't, I don't show, but that's all part of the parts list, and I'll give you the exact manufacturer model number. But it's actually in the parts list. Y strainer. I think we have a T strainer here instead. Same design, it's just a T instead of a Y. 40 to 60 psi on average, the higher the better, the pressure, and automated through the solenoid control valve. When it's depressurized, all the water runs out of the system down to the water level of the tank. And operating, your guys' choice of operation is how you feel it works best for your plant.
Right, on that,
yeah.
There were some situations last summer we wanted to run it longer than 4 hours, but that Hunter unit out there didn't let us. Am I understanding that correctly?
I guess they had to set up like 4 hours and 2 hours, or
had to set up in sequential 4-hour sections.
yeah.
So like if you wanted to run it for 6 hours, it didn't let us do that.
I think you have to do 4 and 2 with that model.
Yeah.
And you can run it 24 hours a day. I think they have 4 start times, and each start time can run 6 hours, or 6 start times, and each run can run 4 hours. So that you can run it for 24 hours a day. You just have to set up your start stops.
Okay.
But then you sequence them in a row. And all those manuals are also online at Hunter. So if you don't have the manual, you can go online and download.
That's AJ's job.
Okay. You can download.
We just run them during the day shift anyway.
Yeah, and you and I had talked about it. Yeah, there's no issues that one. But obviously, use the reuse water, solenoid control. We went through all that. Went back, self-propelled, multiple nozzles. Now, the spray bar that you have now with the 2 nozzles on each side, that's our base. I also have units where we have nozzles in the middle as well. 1 nozzle in the middle, and then the two nozzles on the outside. And it's all based on the amount of water volume you have available at the tank. Most facilities do not have more than usually 60 to 70 gallons per minute at each tank, so I try to keep the water usage down in the under 20 to 30. But
Well, I don't think we haven't had any trouble with the
Some
cleaning.
water.
oh, sure, great, thank you, sir.
Great.
Yeah, I don't think we have any problem with that.
Okay, and that's also getting into that. If you step up your nozzle size, you can use more water,
Get more,
but you'll get way deeper penetration, and then you can still maintain your faster speed, so you don't have any stoppage. And that ties into then also extreme water usage at a smaller plant like this. If you have large water users that come on, like if all your irrigation turns on at the same time, and your water pressure goes from like 65, 70 down to 35 during that event, that's going to affect the rotational speed of your rotating spray bar as well. So that during your low pressure times, it's going to slow way down. Or a lot of plants that have 50 pound pressure deviation.
wow.
They'll go from 70 to 20. They have 3 belt presses that turn on, and then the sprinklers turn on at the same time. Then the belt presses get clogged and they can't. Junior operators that run the night shift don't really care that much. So then I get phone calls that the Weir washer's not working. I'm like, so what time? What's running? And I have to do the simple water usage problem for them. Approaching the multiple nozzle combinations. The rotating spray bar having the 4 on the end, that can be increased to 1 in the middle. That would do nothing but spray down the middle of that channel between your center feed or your scum baffle and the weir teeth, that deep water section. And so as it's rotating, that's doing nothing but drilling down that middle section. And then the 4 other ones, they come through and hit pulses in there. But with having that one smaller one in the middle makes a big difference on that center channel, because it does nothing but constantly stir it.
It's the same area to go around.
Constantly hits that baffle section. So that's just one of the things that when I come out to plants, I like to, even if you guys send me a picture of what you're doing and what the spray pattern looks like, I know exactly I mean, I have a pretty good idea of what's going on, the operational speed. You send me a still photo of the rotating spray bar, I can tell you how fast it's rotating based on the angle of the water coming off of that nozzle. If it's shooting like this, or the nozzle's like that, I know the thing's going like crazy. And you're only going to penetrate a 1/16 of an inch into the water. You guys weren't going that fast, so you still were getting some penetration in the water. And to aid that, just try some larger nozzles, and I'll get those. I'll leave them with Arcilio or with you guys, and you can squeeze them into the other one too and try what works best.
Two small ones and two large ones, see what it does.
Well, right, and that's where you can play with. Even if you add one larger one, that may be enough to just drill that deeper, just enough deeper in this section, and yet not offset your water pressure on the unit enough to have any impact. Yeah, the water spray, because it rotates, we're able to break up everything from foams to obviously algae and greases, whatever accumulates on the surface. So beyond just secondary clarifiers, we have primaries and thickeners that we've installed on. And we're working on digesters now in Oregon to try to keep their foam and other materials from overflowing out their vents.
They add water to their digester?
Periodic. So they know when their float's coming up. They know when they're puking. And so they have to go in there with a fire hose anyway and knock it down because it's running out into the lawn. And now they've set up an actual receiver that goes to a hose that goes to a tank as they get it knocked down so that it... Yes, they have plant operational problems, and they're addressing that. But by the time you find a problem, as you guys know, it takes 3 to 5 years before you can get it approved, get it. So in the interim, our system, instead of sending a guy out there with a gas mask on and hosing that nasty crap down, just throw a valve, knock it down.
Floating dome?
No, fixed dome.
Fixed dome?
But they're foaming out the top, and they have a couple industrial issues that they're trying to deal with. But nobody ever has any problems. High schools never dump lots of bleach down their toilets or anything like that. So, yeah, it's an operational issue, and a lot of times I come in and provide the 3 to 5 year gap to fix the problem until they can add another, whatever is in the process. A lot of times it's a wasting issue. So that's the Weir washer aspect. So as far as the center unit, the spray apparatus we're going to discuss now. But the center unit, the piping, and the controls, we covered a lot of that. Is there any specific questions?
Our secondary number 1 with the apparatus starting on it.
Right.
When it first was installed, a few times it wouldn't retract, so they had to adjust it. So
we talked about that. So what happened there was we had a backing nut on there that locked it in place. Somehow it wasn't tightened enough, and it must have worked itself off and fell off. So now it's welded in place. It's got a 3/8 heavy tack on there that locks it in place.
Okay, you okay with that?
Yeah, that'd be fine.
And it's right on top so that you can access it with
As long as it doesn't turn.
You get access it with a die grinder. If you do ever need to adjust it for some reason, just chop right into it like a normal tack. You can see it. It's right there. And then
on secondary clarifier number 2, on the new install,
right.
It got hung up a few times.
And we're talking about that. We're probably going to have to put a double elbow there instead of it coming straight in. So it comes over here. And that nipple rotates inside the pipe, so you don't have to take anything out. You loosen the clamps, it'll just rotate in there like a union. And then you spin a street elbow on there and just screw it into the side, and that should clear it. So here's yours, obviously. It was there. This was here a long time ago.
it's our first one you
Yeah,
installed.
I think you were here. Yeah. And that's where I was working with copper because I was doing all the R&D, and then I was ready to build the final arm. This part just had to be built in stainless, and it ran for 3 weeks with the copper until the copper failed. So I was going to replace it with my standard 2-inch welded stainless piping, and I was actually just going to roll it, so it was one piece, no weld. We took a 9-year hiatus. Well, I think it was 8 years.
Probably pissed off somebody.
Me? No. No. I think it was a lot more than just somebody. Yeah.
We had to take that clarifier
Up and down, up and down. I know. Yeah. But because of all those efforts that you guys did, we now have here. You guys are the reason why this all is happening.
That is true.
After I got to this point, I figured out the geometry. I mean, I first started with this, And that was, yeah, fraught with not working. And worked to this point, and I was ready to make the finished product. And then, not only did you guys get burnt out, I got burnt out also. And I needed a good 5 or 6 year break. And I had a couple of other opportunities. We have many, many now opportunities that we're going to be selling next year outside of inland. It's a common item now. So basically, here's your spray, as you know. But as I mentioned, you can put one nozzle right here in the middle so that it does nothing but circle like this. Instead of, as on the larger radius, it's cycling and it comes by at a velocity and it pulses in there, but it doesn't have a chance to drill through. We're putting one nozzle right here that just does nothing but circle right here. It'll drill down into that area and get. And because it's on a no radius, quarter-inch radius, it's rotational time, and it can sit there and really dwell and dig into these channels of the scum baffles.
See down there, that bar, that going across what's on top, and you reverse it on this new one, which is a lot better situation, I think.
But the other one or this one?
With the new one.
Okay.
Because it's on the bottom side, isn't it?
It gets closer, yeah.
Yeah, and not only that, you don't have that interference from the bar coming across on top.
Right.
But if you put that nozzle right on top, it's more.
Right, right.
Instead of breaking up.
It's going to hit it
yeah.
as it goes across. Right.
So there's an area there that you're missing every time it does that.
But as you can see, once it passes it, it still works inside that area.
Yeah.
So, this arm here, when we first designed it in Vegas, we called it the swinger weight. You're welcome. But now we call it a gravitational assist. Yes, swinger weight's still what it is. But basically, once you get this arm and that much metal out on the other, hanging out of there, once it passes that center of gravity, we had to balance it off. The problem is you can't just put a weight back here, because as it swings up, you then lose any additional weight, and you offset the weight here until you don't get a full submergence. So we had to figure out how to get a weight that only helped you on that first 20 degrees of drop. Because at that point, then you pass your center of gravity of this whole arm, and the arm's weight itself will drop. So that's where we came up with swing weight. Swing right on the end, and she only engages when you need her. But now with the new unit, as we'll see when we go out, the water supply literally runs down the 2x4 beam straight into the swivel, and then an elbow is welded to the side of the swivel, and then off the side of that elbow is a 1-inch shaft that goes into a 1-inch
beam. Into like a square tubing or something?
Yes, yeah. And then we just have a 2x4 on the face, actually. You're right, yeah.
So
it's so much lighter.
And then that's coming off of that going into the front part of the ram.
And then instead of the vents all being out here, they're right here on the main 2x4, or it's a 2-inch square tube with 5/16 wall, no, quarter-inch wall. So it's real heavy tubing. And that's the main structure component on this piece, and it vents and supplies the water out to it all. It's very compact, very light. It's not easy to pick up if you guys want to go out there, but it's not hard. It's not as heavy as this monster is. You two guys could wrestle it out of there. So, but you guys got boom trucks, you just pick it up and eek. And it is, as we developed with this one, each of its connection points are bolted on so that it can be unbolted and lifted out and put back on very easily. But basically, here's your, and you can't see with the light on here. Water supply cylinder there, cylinder rod, your articulating wheel there, and the arm. And here's your structural supports that run down, and it's bolted there and there. Total of 6 bolts to take the arm off. Once again, just different. And like, so we'll go out there in the torrential rainstorm and take a look at it all. Proc switch is all happy? Okay. And as you guys experience, control box controls it off and on. How the electrical wiring works, the proc switch senses a piece of metal that's connected to your existing vertical structure, or actually your clarifier drive gear casting itself. As it passes underneath this proc switch, it opens the circuit. And it's a metal sensing proximity switch, so that any metal that passes underneath that proximity switch opens the circuit. And it's a simple series 24 volt DC circuit. Literally, it's just a loop with the valve, the proc switch, and the timer, all in one loop. So the power comes out, goes through valve, goes through proc switch, back to, so either one of these open, the valve closes and the arm falls. If you turn it on, as you've experienced, I'm just going to go through the obvious things. You turn it on when the proc switch is over the metal, it won't come up until it passes the bridge. And then it moves forward. I don't know if I have too much more. Here's the metal. Here's just a couple different designs. This is, I think this is your clarifier here, the first one. And then this is another, I think this is Vegas, where we just knuckled on there and then we're able to move it back and forth. And once again, the proc switch running over them. And that's the basics of it. And then we'll get the rope safety switch you guys have done. But that we tested and hit the safety switch, turns the drive off, and reset the safety switch, just like the one you have on the other.
Yeah, that was a good addition. I think that saved us once.
Yeah, when the adjustment.
Is it more than once?
Yeah,
Oh, yeah.
Because when it had fallen too far forward, it wasn't falling back on its own.
Right.
So.
But there's so much torque on that cable once it gets hooked on there.
Right.
Fair to get off.
Unhooking it, yeah. Yeah.
The design you had years ago, it would retract underneath. It didn't retract naturally.
Right.
That was nice.
Well, this tubing is 16 or no, it's 40 thousandths thick stainless steel tubing. It's not pipe. So if something goes wrong, that tubing will just snap right off. I've had clarifiers rip that stuff in half before, and it has to be that way. I'd rather break my arm and give you a whole new arm and fix it than fix a clarifier. That's a nightmare. So the arm's easy to fix. Cut off, weld new on, all good. Clarifiers.
So you have to make the clarifier to go out to the arm.
Well, right. Well, normally they don't break off; they just break in half. You create their own clearance. 60 to 80,000 torque, foot-pounds torque. It'll bend that pipe without a problem. So as far as any questions in here, as far as the spray apparatus design configuration, all the feedback you gave me and that you and I had talked about were now incorporated into these new two units, plus the unit that we built after that one that we tested ourselves in our own test tank to incorporate and prove some ideas. The rotary bearing itself has
You did, didn't you?
Hated that thing.
it's got a Zerk fitting on it. This is the main rotary bearing that's on there. So no, that down
Oh, the
below.
one, okay.
Yeah. So when and if you drain the clarifier, it's completely sealed and it's at 60 degrees and it cycles 1/4 of a turn an hour. I don't think we're going to be losing a lot of grease there. I've had these rotary bearings that I've used on a vertical application above water in the rain never be greased in the last 7 or 8 years. So we greased it before we shipped it, so I'd say check it once a year or whenever you go into the tank, once every 2 years. Just give it a shot. That's it. The other bearing is all stainless steel. So there's only those two moving parts. The chain is chain. Keep an eye on the chain after 5 or 6 years. It's 5/16 stainless steel chain running on, probably run for 20 years.
That trough that it runs in, I can see where it's going to start wearing, eventually.
Right, and you'll see. And that's the thing, it'll be obvious.
Yeah.
It'll be obvious when you get that wear on there. But it's such a slow movement, and that chain's rated for 4,000 or 5,000 pounds. We're putting 100 pounds into it. So, yeah, it'll be a while. You're not going to put, and it's not, there's no twisting moment on there. So there's no real slide. It just comes up and it's a synchronous movement. So, it'll slide a little bit, but we don't have any dragging event.
It's going to last 6 more years. That's
Well, I got a name before then.
Well, my goal with all of these items is 10 years is what I shoot for everything, or more. That's where any feedback you guys have. I don't have a clarifier yet in my backyard. Yet. I got a big test tank, but it's not a clarifier. So, thoughts, ideas?
So you don't recommend any kind of a spare parts list to keep on hand here, huh?
Yeah, so the cylinder is from SMC. It's I think $500. So
what about the swivel part?
those are $100.
Those things wear out very fast?
It depends on speed and rotation. So if you take your spray bar and you rock it, that's basically, if it's tight, you know, it's more of an optical thing. You'll be able to see it starting to rock. You'll see more water start to spray out the side of between the stationary and the rotating component. Yeah, and it's self-flushing as well. But as they wear, then they get a little bit stickier, which then you have to run them a bit faster. So if you replace them yearly, you wouldn't have any problems with it. They'll easily last, as long as you're not running them at 250 RPM. Yeah. Also, most important part, make sure they tighten so that they're tight. Rotate so they tighten threads. Because they're regular National Pipe threads. You run it backwards, the arm shakes, and then the mechanism shakes itself. Eventually, they work themselves out. So, but slow, and then rotation is such that always tightening the threads, tightening direction. Good? Any more questions? Like I said, just send me random emails. You know.
Yeah.
Go to Weir Wash or go to Gill Trading. You know, keep them clean. I can't get fired, unfortunately. But
yeah, that's what you got to straighten out. I had more trouble having to have a lot of fog out or anything. So.
Yeah, it was just that thing falling forward, and the center of gravity was just off enough. So, and that unit, we actually cycled that unit 500 times in that tank before we shipped it back here. We just cycled it and cycled it and cycled it and cycled it. Tried to rig it. Had one guy not realize he was in front of it, and we opened it up in front of him and it punched him.
Stuff getting inside the cylinder too.
Did
it? We had to get that cleaned out too.
That's about the only thing, pin flock maybe building up inside there.
There's those two things that we have to deal with.
Now I've looked at putting some type of bladder on the backside, but the size of the bladder, because of that volume, filling it with a vegetable oil, food grade oil, something like that to keep it sealed. If you go with the filter's going to clog, obviously, because it's going to suck up pin flock. So you'd have to actually put a big strainer down there. Then you'd have to change that strainer out. So it's one of those things.
Bigger hole in the back. So.
Well, and that's an option. That's something we can look at.
But we haven't had any trouble with that. Once you got it cleaned out and got it forward for it like that. Like I said, since March 27th, I put it on my calendar. We haven't had to do anything to it. Working good.
Good. Yeah, and I've covered the top of the whole structure before. We had critters live in there, and so we learned it's better to leave it open so that you can see what's going on. And that's why that's not covered where we've covered them before. Yeah, it literally completely grew a large colony of biomatter in there. Wow. Yeah, when we took the cover off, it was a cube of
see, I would like
critters.
To the point of where if they drop the level of a little bit and really hose it down, maybe once a quarter or something.
And it's your call.
Yeah.
But we made it robust enough that it'll just pull through that stuff. That cylinder has 300 pounds of lifting force.
Like I said, it's built up on it. The only place to stop with is the sprayer goes across the top of it and tops it off.
Right.
But I mean, they hadn't stopped it any. I mean, we haven't been doing that.
It's actually 550 rough numbers based on your water pressure.
Yeah.
Like I mentioned, we hurt one of my guys once by goofing up on it. Don't stand in front of it. It will knock you out of the way.
Yeah, well, we've seen people standing there and they get them all wet and everything. So.
Well, we did at one time. We did on the Vegas unit. We did have a synchronized ball valve that was mechanically locked, so that the arm would lift because we had a limited water pressure situation there. The arm would lift, and only once it reached the fully up position would the valve then open and allow. It was a spring-loaded valve. The valve would then open and spray. The problem is that spring-loaded valve was not reliable. And so we had to modify it and open up the seals and polish it out so that it leaked a little bit and it was a lot looser, but it still was issues. So I eliminated it because.
Hey, we don't tell you, we just tell them to stand right there.
That's right. It's the if you don't like them.
Like that, wait.
It's really cool. Just stand right here. Get real close. Lean over.
That's why I'm up on the catwalk.
That's right. Somebody else is running the video. Yeah. Mm-hmm. like I said, any questions at all, just shoot them to us. And like I said, the parts list has the cylinder information on it, its model number. It's all in the submittal, and including the 15 pages on the cylinder.
Same, everything's basically the same on both of them?
Yes, the exact same cylinders.
Good,
Yeah.
okay.
Yeah.
And the check valves and the spray nozzles and the.
Yes.
And the
Yep.
bearing and all that's
Yep.
all good.
Mhm.
Good, okay. So I wouldn't have to stock a lot of everything, I have something one item for each, kind of everything.
That's welded in.
Okay, yeah, exactly,
The bearing, the other bearing on the other side's welded in.
okay.
But we have a safety factor of 1,000 rated. We're using it to lift 50 pounds and it's rated for 5,000. Well, I think it's rated for more than that, but
That lasts longer than I'm here.
that's my goal. I don't ever want to be in. Brent Gill,
Thank you.
signing out.